Take a single star like our Sun, already so massive that more than 1 million Earths could fit inside it. Now imagine cramming 36 billion of those suns into one object. Not a galaxy, not a star cluster. One, single, black hole. It's so vast that it bends the very light of galaxies behind it, and so heavy it sits right at the edge of what physicists believe is even possible. Today, we're hunting for the biggest black hole ever discovered, and the answer is far stranger and far more contested than you might think. Welcome back to the channel, where we make the biggest mysteries in the cosmos make sense. Stay with me to the end, because we'll reveal why the biggest black hole isn't a settled fact at all. It's one of the most fascinating arguments in modern astronomy. Let's dive in. To appreciate what we're dealing with, we need a yardstick. At the center of our own galaxy, the Milky Way, sits a supermassive black hole called Sagittarius A. It weighs about 4.3 million times the mass of our Sun. That sounds enormous, and it is. We even photographed it in 2022. But here's the twist. On the scale of the giants we're about to meet, Sagittarius A is practically a lightweight. Astronomers now use a separate word for the true monsters, not supermassive, but ultramassive, black holes weighing more than about 5 billion suns. And the heaviest of these don't just sit at the center of an ordinary galaxy. They anchor the largest galaxies in the known universe. So which one wears the crown? That's where things get complicated and genuinely exciting. For decades, one name has dominated this conversation, and it's a quasar that's been hiding in plain sight since the 1950s. Meet 2N618. It was first spotted back in 1957 by astronomers at the Tonantzintla Observatory in Mexico, who initially mistook it for a faint blue star. They had no idea they were looking at one of the most extreme objects in existence. TON 618 is a quasar, a galactic core so bright it outshines entire galaxies, powered by a feeding supermassive black hole, roughly 18 billion light-years away. For years, its mass was estimated at a staggering 66 billion suns. To picture that, consider this. The black hole's diameter is thought to be 30 to 40 times the width of our entire solar system. You could fit Neptune's orbit inside it many times over. But here's the crucial detail. In 2019, scientists revised that figure downward to around 40 billion solar masses, based on a closer look at the galaxy's dynamics. And that revision points to the real problem at the heart of this whole topic: measuring a black hole you can never actually see. Here's the thing most people don't realize. We have never directly seen a black hole. By definition, no light escapes them. So we can't simply put one on a scale. Instead, astronomers measure their mass indirectly, by watching how fast stars and gas orbit around them, or by studying how their gravity bends light. The catch is that these methods come with significant uncertainty. The most extreme black holes are also the most distant, often in the young, early universe, billions of light-years away. The further the object, the larger the margin of error. So when you see a headline declaring the biggest black hole ever, the honest scientific answer is usually, probably one of the biggest, but we can't be completely sure. This is exactly why a discovery announced in 2025 caused such a stir. Because this time, the measurement was different. It all comes down to a beautiful feature in the sky that Einstein himself predicted: a glowing horseshoe of light. In August 2025, a team led by Professor Thomas Collett at the University of Portsmouth in England announced a remarkable result, published in the monthly notices of the Royal Astronomical Society. At the center of a system called the Cosmic Horseshoe, about 5 billion light-years away, they found an ultramassive black hole weighing roughly 36 billion times the mass of the Sun. Now, that's not the highest number we've ever heard. But what makes it special is how they measured it. They combined two powerful techniques: gravitational lensing, where the black hole's immense gravity warps the light of a galaxy behind it into that stunning horseshoe ring, and the motion of stars within the galaxy itself. Together, these gave one of the most robust, confident mass measurements ever made for an object this size. As the researchers put it, this is among the top 10 most massive black holes ever discovered, and quite possibly the most massive ever reliably confirmed. In a field full of uncertainty, that confidence is the real headline. Other contenders like Home 15A at around 40 billion suns and Phoenix A also have their champions, but the measurements behind them carry larger question marks. This raises a profound question. Is there a limit to how big a black hole can get? In theory, no. There's no rule in physics that caps their mass. But in practice, the universe imposes its own ceiling. As a black hole feeds, it doesn't just quietly swallow everything. The infalling matter heats up and blazes as a quasar, dumping colossal amounts of energy back into its galaxy. That energy actually blows away the surrounding gas, cutting off the black hole's own food supply. It's a cosmic self-regulating system. Because of this, and because the universe is only 13.8 billion years old, astronomers calculate a practical upper limit of around 50 billion solar masses. And here's the jaw-dropping implication. The 36 billion sun giant in the cosmic horseshoe is already brushing right up against that theoretical maximum. We may be looking at black holes that are nearly as large as nature will ever allow. So let's pull it all together. We know ultramassive black holes are real, and we've imaged black holes directly. We know the long-reigning champion TON 618 may weigh up to 40 billion suns, but with real uncertainty. And we know that in 2025, the cosmic horseshoe gave us the most confidently measured, ultramassive black hole yet, at around 36 billion solar masses, sitting close to the theoretical limit of what can exist. The crown, in other words, is still being passed around, and that's what makes this corner of astronomy so alive. So, what is the biggest black hole ever discovered? The most honest answer is that it depends on whether you value the highest estimate or the most certain measurement. TON 618 may be the heavyweight on paper, but the cosmic horseshoe black hole is the one we can stand behind with real confidence. Either way, we're talking about objects tens of billions of times the mass of our sun, monsters lurking at the hearts of the largest galaxies, pushing against the very limits of physics. And with new telescopes coming online, the next record breaker may already be out there, its light traveling toward us right now. If this video blew your mind even a fraction as much as these black holes blow mine, do me a quick favor, smash that like button, because it really does help more curious minds find the channel. Share it with someone who'd love to feel small in the best possible way. And if you haven't already, hit subscribe and ring the bell so you never miss our next journey into the cosmos. Until then, keep looking up. The universe is bigger, stranger, and more wonderful than we ever imagined.